As I said in my last video, I'm going to release series of CCNA lectures which support you to prepare for Cisco certification, especially for CCNA certification. So, on that note, today I'm going to start with chapter 1 of CCNA. The current CCNA certification is 200-301. So, the first chapter of this one, network fundamentals. What we are going to cover today in this topic is we're going to understand the network fundamentals, and then we're going to explain the role and the functions of network components. Especially, we're going to look at routers, layer 2 and layer 3 switches, and next generation firewalls. And then we'll move to a topic to describe the characteristic of a network topology architectures. There are different types of network topology architectures available. So we're going to talk about 2-tier architecture, 3-tier architecture, and then we're going to discuss WAN, wide area network, small office or home office networks, which is called SOHO networks. Finally, we're going to compare the physical interfaces and cabling types. Especially, we're going to look at the fiber, single mode and multi-mode fiber, copper cables, and then we're going to look at the connection types as Ethernet shared media and point-to-point connections, and finally, the concept of power over Ethernet. So let's go into each of the topic. Network components. So, why it is so important to learn internet working? So the answer is network and the networking have grown exponentially over the past 20 years. They have to evolve at a light speed just to keep up with the huge increase in basic mission critical user needs, from simple sharing data and printers to a bigger burdens like multimedia, remote presentations, conferencing. So if you look at the local area network, it's connected via a hub. So you can see here, this device is called hub. So local area networks are initially connected via a hub, which is basically an antiquated device which just connect like wires together. This is typically used in SOHO networks, which is small office home office networks. Keep in mind that a simple small office home office network like this one, this is like a simple very small office home office network, would be considered a one single collision domain and one broadcast domain. We will see later what is a collision domain, what is a broadcast domain. Eventually, the network has grown, the technology has grown, and they introduced new devices on the network. So we got a new device called switch. So things really can't get much simpler than this. So the introduction of switch was one of the best way to control the local area network traffic. So what does switch do? Switch separate or breaks the single collision domain we had in the hub into multiple smaller collision domains. But it doesn't do any changes on your broadcast domain, which means if you send a broadcast on a hub-based network or a switch-based network, that broadcast message will reach out every single end device. But at the same time creates multiple collision domain, which means simultaneously multiple devices can send and receive data with no collision. This wasn't possible in hub. Hub was a single collision domain, which means there's only one device can send and one device can receive at a time. Which means this is a great start, but I really want to know that this network is still just one single broadcast domain. So we still have problem. Let's take an example. If there's some sort of a vital announcement that everyone in our network neighborhood needs to hear about, it will definitely go out to every single one. You can see the hub we have here just extend one collision domain from switchboard, right? So this is one collision domain in the switch, and this is one collision domain. So it just extend one collision domain from the switchboard. The result is that John received the data from Bob, but happily Sally did not, because it is a separate collision domain. So in technically, if you look at it, for switch this is a collision domain, for the hub these are all single collision domain. So the message that passed from John will go to Bob and only here. It won't go there. So that way I can reduce the collisions and reduce the traffic. So from here we can understand in a local area network we have so much traffic. If he had needed to send a broadcast instead of a unicast message, everyone including Sally would have received it. The reason, this entire network is a single broadcast domain. So this causes unnecessary congestions in the network. If you look at the LAN area network has many things that commonly cause traffic congestions. One is too many hosts in a collision or a broadcast domain. If you add multiple devices on a collision domain, which means you're going to extend your network, rather adding switch, you are adding a hub. So if you add hub, all the devices connected in that hub network is still part of a single collision domain. So that increases the traffic. And of course, broadcast tromps. We will learn what is broadcast tromps later on. When you create a network, and if the network has a loop, if one broadcast message is set into the network, then that goes around and around and around. So that's create a broadcast tromp. Similarly, too much of multicast traffic. There are a lot of multicast messages in the local area network. This multicast network traffic is going to reach by multiple devices, not all the devices, group of devices. So that is also causing network traffic. Low bandwidth. The new networks are gigabit and 10G based networks, and they don't have low bandwidth. But if you go back to the old days of networks, or the initial stage of network, the networks were connected using Ethernet cables. They're just only 10 MB per second, 100 MB per second as a fast Ethernet. So this is also creating congestions. So I said adding hubs can create the network congestion. And then the last one is a bunch of address resolution protocol broadcast, which is like looking for IP address to MAC address conversion. So this can also create traffic in the local area network. So you would have a question why we have to convert the IP address to a MAC address. Keep in mind, local area network is a layer 2 network, and they don't use IP address to communicate. They use the MAC address to communicate. So there are a lot of ARP traffic is in the local area network too. So this can create a lot of traffic in the local area network. So moving from hub to switch. Switch doesn't break up the broadcast domain. By default, they don't break it. But we can create multiple broadcast domains using switch, a concept called virtual LANs, VLANs. We will learn this topic in VLAN. But keep in mind, by default, switch doesn't break the broadcast domain. Switch is a single broadcast domain, multiple collision domain. It does break up the collision domain. The switches switch the frames from one port to another port. Layer 2 switching is considered a hardware-based bridging, which is layer 2 switches are much faster than layer 3 routers. The reason, in layer 2 switches, there's a device, hardware device called ASIC is there, so always hardware process is faster than an application-based process. So switches are quite faster to process the traffic. So ASIC can run up high gigabit speeds and low latency, so that with very small delay, you can run high speed network. Switch reads each frame as it passes through the network, which means switch only read the frame when it comes to the switch through an interface. So they don't read anything when they forward it to the other interface. The only time switch reads it when it comes through or when it's passed through the network. And record source hardware MAC address. Every time when you receive a frame, it reads the frame source MAC address. So MAC address is considered as a hardware address. And it's also note down the port where the frame was received. So this information will be kept in CAM table, or we call it as a MAC address table. So that's how switch operates. So if you look at the router operates in a different way. So the router connects multiple local area networks together. So you can see we have got two local area networks and they are connected via the router here. The routers breaks the collision domain, also they breaks the broadcast domain. Every single interface of a router is its own broadcast domain. That's mean in this network I have got two broadcast domain and I have got one collision domain here, there's one collision domain here, there's one collision domain between router and switch, and there's another collision domain here, there's one more collision domain here, and there's one more collision domain here. So this means I have got 6 collision domains and 2 broadcast domains. What happens when router interface receives a broadcast? The router doesn't process the broadcast, it just simply drops a broadcast. If that happens on a switch network, switch just forward that broadcast. If, for example, if I receive a broadcast here, switch will forward that into this interface and it will forward it here. Switch does forward the broadcast into all the other ports except the port it receives. Whereas router doesn't do anything when they receive a broadcast. Router can filter the network based on layer 3 information such as IP address. Remember, in my previous slide I explained layer 2 network doesn't use the IP address to process their frames, whereas they use MAC address, layer 2 information. In routers, they don't use the MAC address layer 2 information, they use the IP address as in layer 3 information to process the communication. This is called routing or packet forwarding.